Hello, AFM students. Today we're going to be in Chapter 5, Section 2, working on long division and synthetic division. Now, before we start Example 1 on long division, I'm going to do a long division problem that doesn't deal with polynomials. And again, the great thing about having a video is that you can take notes, you can pause, you can go back and rewatch certain parts. So we're going to start out with this long division problem. We have the number 12,582 and we're dividing it by 3. Another way you can write this division problem looks like this. The 12,582 is being divided by the 3. Now, when we do long division, we're going to see how many times this 3 will go into this number, but we're going to start with one digit at a time. Since the 3 will not go into 1, you go ahead and look at the next digit. 3 will go into 12 exactly 4 times, and our process of long division is we're going to multiply, subtract, and then bring down the next digit. This is going to be the process we use for long division. So 3 goes into 12 4 times. 4 times 3 is 12. I'm going to subtract, which gives me 0, and then I bring down that next number. And we start the process all over again. 3 will go into 5 1 time. I'm going to multiply, subtract, bring down the next number. 1 times 3 is 3. When I subtract, I get a difference of 2, and I bring down that next number. 3 will go into 28 9 times. I'm going to multiply, subtract, bring down the next number. That's our process. Multiply, subtract, bring down the next number. So since 9 times 3 was the 27, I subtract, bring down the next digit. Now 3 will go into 12 4 times. 4 times 3 is 12, and you see that we get a remainder of 0. There's no more digits to bring down, so 0 is your remainder. So 12,582 divided by 3 is 4,194. Now, this is the way that I learned how to divide in elementary school. Now that this Common Core stuff is rolled in, you may not have ever seen this before, but this is the process. You're going to multiply, subtract, bring down the next term, and that's what we're going to do. So let's try example number 1 on the polynomials. We have this quartic equation, and we're dividing by a quadratic equation. Now, I want you to know as we look at this in standard form, we jump from x to the 4th to an x squared. We are missing that cubic term there. When you do long division, you're going to want to make sure you put in that placeholder. So we're going to take this 4th degree polynomial and divide it by this 2nd degree polynomial. So I've got my 8x to the 4th. I'm going to put in 0x cubes as a placeholder, plus the 6x squared minus the 3x plus 1, and I am dividing by this quadratic equation. Now what we're going to do here, I like to look at it as kind of like a GCF. When I start with this first term here, and I'm going to start with that first term, and it's almost like I'm dividing out like a GCF. And 8x to the 4th divided by that 2x squared is going to leave a 4x squared. Now just like up here, I'm going to multiply, subtract, bring down the next term. So here we go. This is a 3-term polynomial, so I'm going to have to distribute that multiplication 3 different times. 4x squared times 2x squared is the 8x to the 4th. 4x squared times that negative x is a negative 4x cubed. And the 4x squared times that 2 is an 8x squared. Now here's the beauty of putting that placeholder. My x to the 4ths line up, my x cubes line up, my x squares line up. So I like to distribute my subtraction. So since there's 3 terms here, I'm going to subtract that term. I'm going to subtract that term, which changes the sign, and I'm going to subtract that term. Okay? So these are going to cancel. 0x cubed and 4x cubed, that's going to be a 4x cubed, and that will leave me with a negative 2x squared. You bring down the next term. Okay, now we're going to start this process all over again. If I have a 4x cubed and I'm dividing by the 2x squared, that will leave me with a 2x. Now I'm going to multiply, subtract, bring down the next term. 2x times 2x squared is a 4x cubed. 2x times negative x is a negative 2x squared, and 2x times 2 is the 4x. Now I'm going to distribute my subtraction, subtract that term, subtract that term, subtract that term, and I'm going to look at what we've got. That cancels. This one also cancels. Negative 2x squared and a positive 2x squared, they both cancel. So this term is pretty much just left with a negative 7x, and then you bring down that last term. Now notice what I have left here is linear, but what we're dividing by is quadratic. Once you get down to a degree that is lower than what you're dividing by, that's how you know this is your remainder. So our answer is the 4x squared plus the 2x with this linear expression as a remainder. So this is how I'm going to write it. I'll write it as a fraction with my negative 7x plus 1 as the numerator, and this will be your denominator, my 2x squared, oopsies, minus the x plus the 2. Okay, that is your answer when you do long division. Now clearly this is not a perfect factor of this polynomial because you have a remainder. When you get a remainder of 0, that means it divides in perfectly. It is a factor. When you do not get a remainder of 0, then it is not one of the factors. Okay, so this is the process for long division. Now we're going to jump and do an example of synthetic division. Okay, so this is example 2 from your textbook. We're taking this 5th degree polynomial and they wanted us to divide it by an x plus 2. Okay, so what we have to do for synthetic division though is we are going to use these coefficients. And again, I want you to notice I go from degree 5 to degree 4 to degree 3. I am missing the degree 2. Then there's my degree 1 and my constant. So when I write out all of these coefficients, I will make sure I put in a 0 for that missing term. Okay, so we have the 3 for the x to the 5th, a 5 for the x to the 4th, negative 4x cubed, 0x squares, 7 x's, and a constant of 3. It is very, very important that you put in that 0 as your placeholder. Okay, now in this example, they told us that they wanted us to divide all of that by the factor x plus 2. Now here's the thing. If the factor is x plus 2, when you set that equal to 0, the solution is actually negative 2. So when you do synthetic division, since we're only working with numbers here, you're going to divide by the solution, not the factor. Okay, so I've got all of these coefficients here, including the 0 for the missing piece, and I'm dividing by the solution to that particular factor. When you do synthetic division, you always start by bringing down that first number, and we are going to multiply and add columns this time. Okay, so I'm going to bring down that 3. This is synthetic division. So the negative 2 times the 3 would be a negative 6, and I add that column. Do it again. Negative 2 times negative 1, that would be a positive 2, and I add that column. Negative 2 times negative 2 would be a positive 4, and I add that column. Negative 2 times 4, that would be a negative 8. Add that column. Negative 2 times negative 1 would be a 2, and when I add that column, this is what I get. Now, I want you to notice that that is going to be your remainder. That's the number at the back. So here's the trick. These numbers that we have here are the new coefficients. Since we started out with an x to the 5th, but we're dividing by an x, that means when we subtract those exponents, this is the first answer. That would be an x to the 4th. An x to the 5th divided by an x is going to get x to the 4th. So that's the first coefficient for my x to the 4th. So my answer is actually 3x to the 4th minus a 1x cubed minus a 2x squared plus 4 x's minus 1 is the constant, and the back number is always your remainder. So I will write it as a fraction, just like I did in the previous example. Synthetic division is much, much quicker because you just take those coefficients and are only working with the numbers instead of all those polynomial terms. Here's the thing though. Synthetic division only works when you are dividing by linear stuff. That's why it's really important to know how to do the long division, because long division is when you're dividing by something that's not linear. So it's important to know both of these methods. Okay, the last thing that I need to show you is going to be example 4. This is where we're kind of working backwards. They're giving you the zeros. Remember, these are the solutions. So we're going to go backwards to rewrite them as factors, multiply all this junk out so that we have our final equation. So if the zeros in example 4, if the solutions are -3, 0, 1, and 5, that means if we work backwards, before we got the solution of -3, the factor was an x plus a 3. If x is 0, the factor was just x. For a solution of 1, the factor is x minus 1. For a solution of 5, the factor is an x minus 5. Now all I have to do to come up with the original equation is just multiply all that stuff out. So I'm going to very quickly multiply all these together. I'm going to multiply these two together, multiply those two together, and then I'll multiply my final answer. So here, if I multiply these two, I'm going to get an x squared plus a 3x. Let me write that down. X squared plus 3x. That's one of my products here. If I multiply these out, I'm going to get an x squared. A -5x and a -1x will give me -6x. And then that plus 5 will be at the back. Now I've got to go one step further, multiply all these out. Okay? So I'm going to distribute my x squared to all three, and then I'll distribute my 3x to all of them and combine like terms. So x squared times x squared, I've got an x to the 4th. X squared times -6x, I've got a -6x cubed. X squared times 5 is a 5x squared. 3x times an x squared is a 3x cubed. 3x times that -6, I've got a -18x squared. And then I've got that 15x at the back. Now, once you go ahead and combine like terms, then you will have your final answer. So I've got 1x to the 4th. I've got -3x cubes. I have -13x squares. And I have 15 x's. This is your original equation. When we factor it, we would get these factors. When we set our factors equal to 0, we would get these solutions. So we're kind of working backwards. Yesterday, we started out with the equation. We factored the equation and then set the factors equal to 0 to do our graphs. Now we're working in the reverse direction. Okay, so today we've got some long division, some synthetic division, and some writing equations given the solutions. Please email me or call if you have any questions.